This video discusses lines. Lines are of the form y equals mx plus b, where m and b are real numbers. This value m is the slope of the line, and this value b is the y-intercept. So the graph of a line looks like this. So if you plug in 0 for x, if you have x equals 0, then the height y is b, which is the y-intercept. So let's say b is here. And if I plug in x equals 1, so let's say this is x equals 1, I get y equals m plus b. So here is m plus b. This is another point on my line, and so the line looks like this. The slope of the line measures how steep the line is going up or down. So if I have a slope that's a lowish number, but still positive, then my line will be going up slowly. So this is a low positive slope. If I want to draw the graph of a line with a negative slope, then my line would be going down. So a negative slope looks like this. So negative slope. And if I have 0 slope, then my line is completely flat. It's not going up or down. So this would be 0 slope. If I have a 45-degree line, for example, the line y equals x, if I have a line that's going up at 45 degrees exactly, then that is slope 1. If I have a line going down at 45 degrees, then that slope is negative 1. And if I have a line going straight up, then there is no slope. So let's see some examples. So what is the slope of, let's say, the line 3x plus y equals 2? Well, in this case, I'd like to write my line as exactly this form, y equals some mx plus b. So I need to solve for y exactly. Actually, maybe to make this problem more interesting, let me do 2y. So I'm going to solve for y exactly, and that means I'm going to subtract 3x on both sides. So if I do that, I get 2y is negative 3x plus 2. Then I'm going to divide by 2 to get negative 3 halves x plus 1. Therefore, my slope is negative 3 halves. You can also calculate slope from the graph of an equation using the rise over run idea. So if I graphed this equation, the y-intercept is 1. So here I'm at 1. And if I plug in another value for x, say if I plug in 2 for x, so 1, 2 for x, then I get negative 3 plus 1, which is negative 2. So I'm right here. My line goes this way. You can calculate slope using rise over run, meaning you measure how much the function rises or falls over how far it travels horizontally. So in this case, it drops 3 steps over the span of 2 steps horizontally. So rise over run is negative 3 over 2. Another way to calculate slope from the graph of the equation. Two lines are parallel. Actually, let me say my two lines. Let me give the actual equations for them. So my lines y equals m1x plus b1, and let's say y2 is m2x plus b2. Two lines are parallel if their slopes are the same. So parallel lines have the same slope. That's because parallel lines are either going up or down at the same rate. Likewise, these same two lines are perpendicular if the slope of one is negative the reciprocal, the slope of the other. So why don't we see an example to finish the video of perpendicular lines. So let's look at the lines y equals 2x plus 1, and let's say that's y1, and the second line may be negative 1/2 x. So let's plot both of these lines on the same graph. So the first line I will plot in red. So the y-intercept of the first line is 1. So here's a point on the first line. And the slope is positive 2, meaning it's going up. The slope is 2, so if I plug in x equals 1, I'll be at 3. So here's 1, 2, 3. Oops, my line's over here. So this is my first line. My second line I will draw in pencil. That's the line negative 1/2 x. So if I plug in x equals 0, I get out y equals 0, so there's a point on my line. And if I plug in x equals 2, I get out negative 1. So 1, 2, I'm over here at negative 1. Here is my second line. And if I drew them correctly, you might be able to tell that these two lines are at 90-degree angles from one another. They are perpendicular. Okay, there was a very brief introduction to lines. Wonderful.